JEE Main 2026, 2nd April Shift 2, Physics Section B, Question 49. Let us visualize the setup. Sunlight, which consists of parallel rays, falls on a convex lens. The parallel rays converge at the focal point of the lens. A piece of paper placed at this focal point starts burning. The lens is held 30 centimeters above the paper, so the focal length of the lens is 30 centimeters. The radius of curvature of the lens surfaces is given as 60 centimeters. The question states, if sunlight is focused on a piece of paper using a convex lens, it starts burning when the lens is kept 30 centimeters above the paper. If the radius of curvature of the lens is 60 centimeters, the refractive index of the lens is alpha over 10. Find the value of alpha. This is a numerical type question. The key concept here is the Lensmaker's equation. For a thin lens with refractive index n, the equation relates the focal length f to the radii of curvature of both surfaces. 1 over f equals n minus 1 times the quantity 1 over r1 minus 1 over r2. For an equiconvex lens, both surfaces have the same radius of curvature r using the sign convention, r1 equals positive r and r2 equals negative r. Substituting, 1 over r1 minus 1 over r2 becomes 1 over r plus 1 over r, which equals 2 over r. So the simplified formula is 1 over f equals n minus 1 times 2 over r. Step 1. Identify the given values. The lens is kept 30 centimeters above the paper, and sunlight, which consists of parallel rays, focuses at the focal point. Therefore, the focal length f equals 30 centimeters. The radius of curvature r of the equiconvex lens is 60 centimeters. We need to find alpha, where the refractive index n equals alpha over 10. Step 2. Apply the Lensmaker's equation for an equiconvex lens. 1 over f equals n minus 1 times 2 over r. Substituting f equals 30 and r equals 60, 1 over 30 equals n minus 1 times 2 over 60. Now, 2 over 60 simplifies to 1 over 30. So we get 1 over 30 equals n minus 1 times 1 over 30. Multiplying both sides by 30, we get 1 equals n minus 1. Therefore, n equals 2. Step 3. Find alpha. We are given that the refractive index n equals alpha over 10. We found n equals 2. So, 2 equals alpha over 10. Solving this, alpha equals 2 times 10, which gives us alpha equals 20. The correct answer is alpha equals 20. Starting from the burning distance of 30 centimeters as the focal length and the radius of curvature of 60 centimeters for the equiconvex lens, the Lensmaker's equation gives us a refractive index of 2. Since n equals alpha over 10, alpha equals 20. Here are some important exam tips for ray optics. Remember the Lensmaker's equation and its simplified forms for equiconvex and planoconvex lenses. Tip 1. When sunlight is focused on paper, the distance at which it burns is the focal length, because parallel rays from the sun converge exactly at the focal point. Tip 2. When the question says radius of curvature of the lens in singular form, assume it is an equiconvex lens with both surfaces having the same radius. Tip 3. Always apply the correct sign convention. For a biconvex lens, R1 is positive and R2 is negative. Getting the signs wrong is a very common mistake in JEE. Like and subscribe for more JEE Main solutions at MAGPIEHUB.